Hello students, today we are going to discuss a very important topic of C, that is type conversions. So before starting with the main topic, let us see what is type conversion. So type conversion in C is the process of converting one data type to another. The type conversion is only performed to those data types where conversion is possible. So type conversion is performed by a compiler. Now we are coming to the types of type conversions. So dear students, we have two types of type conversions in C. One is the implicit type conversion, the other is the explicit type conversion. First we will study about the implicit type conversion. The implicit type conversion is done by the compiler on its own without any external trigger from the user. Generally takes place when in an expression more than one data type is present. In such conditions, the type conversion takes place to avoid any loss of data. All the data types of the variables are upgraded to the data types of the variable with the largest data type. As you can see here, I have given a chart. Here in this particular line, you can see the data types arranged according to their sizes, starting from the smallest to the largest. So it is possible to do implicit conversions, and there are possibilities where we lose information. The signs can be lost and overflow can occur. First of all, remember one thing, dear students. The implicit type conversion is done by the compiler, and it is assumed that the user here does not really specify that he wants to do a type conversion. It is automatically done by the compiler. Now coming back to the losing of information part, let us see in bit details what is the meaning of that. Now here, as you can see, I am coming to the last point which we have seen in the previous slide. Okay, and I am just elaborating on that point. So first of all, when a signed integer is implicitly converted to an unsigned integer, the sign can be lost. Okay, so if the signed integer is negative as it is shown in this example, it will be interpreted as a large positive value when it is converted to the unsigned. Let us see the example to understand it in a better way. So the example says that int a is equal to -5. So here a is a variable of integer type. What did we do now? We have taken an unsigned integer b and we have put the value of a in b. What is the problem here? A, as we know, was an integer. B, as we know, is an unsigned integer. So negative value is not allowed in unsigned integers. What happens here is that the negative value becomes a large positive number. And the output, if I print B now, I can see that the output is a large positive value which has no relation at all with -5. So dear students, what is the problem here? After implicit conversion, the original value is lost along with the sign. Coming to the next point. When a large integer type like long or long is implicitly converted to floating point type, that is float or double, overflow or precision loss can occur. This is because floating point types may not have enough precision to represent large integers exactly. What happens here in this example? We see that there is long integer called x which has a certain value. I have put the largest possible value for a 64-bit signed integer here. As we are converting this to float, what happens is the loss of precision, or there is an overflow. So as we all know that long int has a bigger size as compared to float. So what happens here is that the output which we get is not at all matching with the original value, as you can see here. So it has changed. The last second last example which I wanted to show you is that when a floating point type is implicitly converted to an integer, the fractional part is truncated, leading to a loss of precision. What happens here? We have a floating point number a whose value is 3.14. What are we actually doing here? We are putting the value of a into b, which is an integer. What happens here is that the fractional part of this number, that is 0.14, is lost forever. If I print b now, I can only see 3 in the output. The last one says when a large integer type like long or long is implicitly converted to a smaller integer type like int, the value can overflow if it exceeds the range of the smaller type. For example, we can see a long number here, which we are converting implicitly into an integer b. In this case, overflow occurs. B might get an unexpected value. If you print B here, dear students, you can see the output as -1, which has no relation with the original value. So, just for your better understanding, I have made a chart here which will tell you the size of each of the data types which I have mentioned in that chart. Just an easy example. What are we doing here? We have an integer called x which has a value 10. We have a character y with value a. What did we do here? We wrote x equal to x plus y. But y is a character here. What will happen here is that y will be implicitly converted into its corresponding ASCII value. What is the ASCII value of small a? It is 97. So what happens here is that this here x is 10 and y is 97. So x now becomes 107 here in this line. In the second line here, that is float z equal to x plus 1.0, we see that x was originally an integer which we are adding to a floating number. What happens here is that x is implicitly converted to float here. Here is a chart of the ASCII values if you want to refer. So small a is 97. Now we are coming to the second type of type conversion, that is the explicit type conversion, which is also called typecasting, and it is user defined. Here the user can typecast the result to make it of a particular data type. The syntax in C programming is type, like the type to which you want to convert, and your expression which you are converting. So the type indicates the data type to which the final result is converted. Coming to a very simple example here, we have a double called x whose value is 1.2. We are implicitly converting this double into int by typecasting. What happens here is that the point part is lost forever and this value, that is int x, becomes 1. So what is the final result? That is 2. Let us see another example here, which is a very classic example of explicit type conversion. Here a is 10 and b is 3. We can see that we have divided like a by b and we have stored the corresponding result in result implicit, which is float. So here what happens is that implicitly the result is converted to float. What happens here is that 10 by 3 is integer divided by integer. The result is also an integer. So the value of a by b is 3. When we are converting it to float later, the result will be 3 point, then 6 zeros. But what happens in the second case? Since we have explicitly converted a to float, here a is initially converted to float and becomes 10 point, then 6 zeros divided by 3. So what happens here is that explicitly this b is also converted to float and the result becomes a floating point, that is 3.333333. Thank you so much, students.